We're here to talk through his Slitherlink Switch variant by Matej Uher. This is one of the variations in his Slitherlink ebook. And let's start. So, there are a few markings I'll be using here. The first of which is when I go with a number, when I find a pair, I'll be marking with a circled number on top of it. And the other marking is I'll be doing a green surface marking for clues where I know what their value is. So, for instance, this cell actually can only pair up with either this two or this two. Either way, since it pairs up with a two, I'm just going to mark it in green to make myself remember that that is going to be a two no matter what, as in I know its value. So those are the markings you'll be seeing. Now, getting to this puzzle, the first row, I look at this. So 0 and 3 is a pattern on the edge that can never happen in Slitherlink. So let's say this 3 and this 0 pair up. You can immediately see the contradiction. You have no place for this strand to go. So generalizing it, you never get a 3 and a 0 on the border. So that means this 3 can only pair with the 3 to its right. That means we can just put in two threes. We know that that's how it happens. Now let's just mark this regular Slitherlink pattern. Now looking at this 2 here, which we have made green, this is another pattern which is actually not possible in regular Slitherlink, where you let's say you have a 0 over here. What ends up happening, as you can see, is this you need this strand for the 2 to work, and that strand cannot go anywhere because of the 0. So going back, this 0 actually has to pair with the 3 below. So you get a 3 and a 0. And also this 2 and 2 have to pair. There's only one way to do that. Similarly here. Now let's go back to the loop and put in a little more of that. You can't go into this corner. So this is a 2. Now looking at this 3 over here, if it pairs up with this 2, what ends up happening is, so let's say it's easier to probably show. So in this scenario, with the 3 you would force this, but with the 2 you would actually force this, and this causes a branch. So this whole possibility is not valid. So that means this 3 has to pair with the 1. So you have a 1 and a 3. And now we look at some more of that marking which I said. So this 3 can be marked green because no matter what, I know it's going to be a 2 because both of its neighbors are a 2. Similarly, this 3 has to be a 2. And also now this 2 has to be a 2 because we actually know that this is a 1. So it can only pair up with the 2 next to it or the 2 next to it. Similarly, this 2 as well, this 2 as well, this 2 as well, and this 2. This is just a way to remember for later. So this being a 2 means that we get this. So it's actually a corner over here. So it's either this way or this way. Again, a common Slitherlink pattern. Now this being a 2 and this being a 2, what it means is that this 3 can never be like this because that will, again, common Slitherlink pattern. It will force this over here eventually, and that branching can't happen. So this 3 actually goes like this. Now this 1 actually can't pair with a 2 because this can't be a 2 because a 2 diagonally adjacent to a 0 would either need this or need this, both of which break the 3 area. So that means this will pair with the 3 next to it, and that probably gives us a little more of the loop. Now this 2 over here cannot pair with the 3 below it. So what ends up happening is it has to pair with the 2 next to it. And that forces this. Now, since we know this is a 2, again, this is where the green markings help us. We don't know which it pairs with yet, so we won't put the circled number. But this is a 2, and that means that forces this. And also this 1 forces this. These 2's force this. So this 2 forces this. Now, actually, because of this 1, we can cross these off and this gets forced. So now we know that this 2 has to pair with the 3 because it can't pair with the 2. So 3 and 2, and again 3 and 2 get forced here. And we force this much. Now, now let's look at this portion at the top. If this is a, so this 3 actually would have to go here or here. If this is a 3, that breaks this being a 2, because as you can see, this will get forced. So the 3 actually ends up going here. That means these two are paired. We know that now. And also this gets done. And also now this 2 can only pair with the 1. So this is a 1 and a 2. And that gives us a little more progress on this side. And also this 2, I think, can't be a 3. Yeah, this 2 can't be a 3, because if it's a 3, that forces this pattern for 2 diagonal 3's, and that causes a branching. So this 2 actually has to be a 2, and that can only happen if it pairs with this 2. That forces this pairing and this pairing. So this 1 actually can be green because we know it's a 2, and that means you get these crosses. Now this 2 also actually can be greened because it can't be a 3. So the only neighbors it has that are valid are 1's. So this loop strand forces this because of the 2, and right. So this 1 can also be greened because it has to be a 1 either way, and that means we get this and this. We can probably see that, so 3's are generally pretty powerful. This 3 over here, this one over here, obviously can't pair with this 2 because this corner forces this to be less than 3. Can it pair with this 2? If it does, then what happens is, so we see a cascading pattern here. We know all of these are 2's. So this will actually either go this way or this way. Either way, this can't be a 3 because that would force this. So this 3 actually ends up pairing with the 1 below it. So there's a 3 and a 1. And that forces, actually, no. So this 1 being here gives us these 2 crosses, and that means since we know this 2 is a 1 value, forces this, and this gets forced as well. So we can put some more crosses in. So this 2 over here cannot actually be a 2, because that would again break this cascading series of 2's. So this actually has to pair with a 1. That can only happen like this, and that actually gives us a lot of pairings. This is forced, this is forced, this is forced, and basically all of these. So we got a bunch of known pairings now. Now, another common pattern in Slitherlink, which is actually impossible, is three triomino and L triomino of threes, because we know that this happens for diagonal threes, for instance, but this adjacent three would actually force this for the top three and this for the left three. Either way, there's some branching, there's a lot of problems. So actually, these two threes can't pair with each other. That means this three has to pair with this one, and that gives us this. And actually, let's pair these two twos as well, because that's forced as well, and that gives us some more progress here. These are all classic Slitherlink steps. Now we can resolve these twos because of this one over here. So all of this gets forced, and this for these twos as well. So this segment over here to the top right of this two means that these two crosses are there, because it will pass through. You need a one here or here for it to work. Um, so this three actually is a green digit, because it can only be a two because of its remaining neighbors, and a two will force, so you can't have these two as segments, so it will force this at least. Now that forces this, so this cannot be a three now, this cell. So that means the three has to pair up with the two below, and that means these two also get forced as a pairing. And because of the one now, we get some more progress. Now this one is also a green digit, because we know it's a one, both of its neighbors. So this zero is actually pretty powerful. If it pairs with the one below, what ends up happening is you get a one here and a one here. Let's just kind of try it out, because this is a little bit of a look ahead. So let's say both of these are vertical pairings, right? Let's look at it that way. So if this is a 0 and a 2, and if this is a 1 and a 1, you can kind of see the immediate issue, because a 1 over here with a 0 over here and a 2 over here that's completed means that it has crosses all around it. That's one way to see it. There's many ways this area just can't happen. So this is one of those ways. So going back, these pairings cannot be vertical. So that means this 0 has to pair with the 2. And this 1 is now a green digit, because we know it's a 1 either way. And that forces these steps. So this is also going to be a 1 either way. Just green it. Now this 1 has been forced to become a 2. That can only happen if it pairs with the 2 below it. That forces some more pairings. And now progress a little more with the Slitherlink. This is green, it's going to be a 2 no matter what. So this 2 could either be a 1 or a 2. This 3 is a green digit, it has to be a 2 no matter what. This 2 is also a green digit. So you get this. We can mark a green cell over here as well, because of this. This one can only be a 2. And that means no matter what, whether this goes this way or this way, this can never be a 2, the cell to the right of it. So that means this one has to pair with the 1, and these two will pair with each other, and we get this much progress. Now, because this is a 2, we know that this is a segment and this is a segment. Now, this 2 clearly can't pair with the 1 anymore, so it has to pair with the 3. So you get a 3 and a 2. Similarly, this 2 as well, because now we have the 3 over here. We need a segment here, or we need a segment here. That means this 2 also pairs with the 3 below. It can't pair with the 1. So that forces this as well and this as well. Now, this is also a green cell because it has to be a 2 no matter what. That forces, so we need a segment coming through here or here. That means we need a segment going through here or here. And that means for this one, it crosses. And also the 3-3 pattern means, okay, so we can't have both of these as segments. It will cause a branch. So this is a segment that forces this much, and also this in this corner. So now a few more green cells. This has to be a 1. This has to be a 1. Now this 1 over here can either be a 3 or a 2. It can't be a 3 clearly. So it pairs with the 2 below, and that forces this to happen. Let's look at the bottom right now. This 2 over here cannot pair with the 0 next to it, because what ends up happening is, if you do pair it up, so let's say this is a 2 and this is a 0, what ends up happening is this ends up becoming a 1 because this has to pair with this. But knowing regular Slitherlink rules, are 2 and 0 at the border forces this. So this can never be a 1. So that means that the 2 in the bottom right corner has to pair with the 3 above it. So that also forces this pairing. Now again, if this 0 pairs with this 2, what ends up happening is you get this force and this, and then you have a dead end here. So a slight look ahead, but that means that the 0 cannot pair with the 2. So that means the 0 has to pair with the 2 above it. It can't pair with the 2 to the left, I mean. Now this 1 and 2 is forced as well. And now we can draw in some Slitherlink, regular Slitherlink logic, some loop strands. And this gets forced. Okay. Now this 1 over here, let's move this highlight. This 1 over here can either be a 2 or a 1. If it is a 2, what ends up happening is these two ones pair with each other. That means you get something like this and a cross over here. So this whole area has 3 loop strands that breaks it. So this, sorry, let me just clean up some of this. Yeah. So now this 1 over here that we saw can't be a 2. So it has to pair with the 1 to its right. That forces this segment, because these are crosses, and forces this segment as well. Now this 1 over here cannot actually go to its right because there are too many segments coming in here. So this one actually will pair with the 3 below it. That forces the 2 2s to pair, and we get this much. And also this. Now let's just mark some of these. This has to be a 2, this has to be a 2, this has to be a 2. And going up to this 3, it can't be a 3 obviously, so it has to pair with the 2 above it. So that means you get a 2 and a 3. That will give some more progress above here, I guess. So now this 2 is remains a 2, so that means it has to pair with this one, and this one has to pair with this one. Now this goes here. Now this 1 cannot pair with the 3 below it, so it has to pair with the 1 next to it. So you get a 1 1. And these markings. Then now this cell actually has to be a 2, whether it goes this way or this way. Then that means you actually get these lines forced, and this as well. Okay, now look at this. If this, look at this area, if this is a 2, that would actually close this loop, close this small section of the loop here. So this is actually a 1, and that means it can only pair with this one. So this is a 1 and 1. This is, sorry, this pairs with this. So this much is forced. Now this is going to be a 2 no matter what. This is also going to be a 2 no matter what. And this. Next, we can see this area over here. If these two ones join each other, what ends up happening is this becomes a 2 outright, no matter if it pairs with its right or its top cell. And that will force this to happen, which will leave this part stranded. So basically, the two ones can't join each other. So that means the 3 and the 1 have to join. And this 1 has to be a 2 no matter what. This 2 has to be a 1 no matter what. And we get some more markings over here. So this 3 has to go this way or this way, forces these crosses, and also this. Now this 1 is a green cell because it has to be a 2 no matter what. And since we know that this 2 is a 1 no matter what, we get these crosses and we get this cross as well. Now this being a 2 makes it resolve like this. Now this has to be a 2, this has to be a 2, this has to be a 2. That means we get a bunch of progress here. Now, now this 2 remained a 2. That means it has to pair with this. This has to pair with this, and this 1 has to pair with this. So that gives us a little more. And since this is a 2, this will all move up. Now this became a 1 over here, so that has to pair with this. So this is a 1, this is a 2. These get forced, these get forced, these get forced, and some others as well. So now we get all of this. This 3 has to be a 2. That's fine. Now this cell over here has to be a 1. So it has to pair with the 1 above. And also force this to happen. So now if this is a 3 and this is a 1, as in if these two pair, then that will immediately break the 3 or break the 1. So those two can't pair up. That means the 3 pairs with the 2 above, and that forces this much. Now this 1 has to be a 2 no matter what. That means we get this and this, and it'll go further here. Now this 2 is a 2, so it has to pair with the 2 above. And that forces this pair and gives us a little more. This is a 1 no matter what. This is also a 1 no matter what. And that means we get some process here and a segment like this and this. Now this 1 became a 2, so it has to pair with the 2 below. So that's the only way that happens. This 2 became a 1. Actually, it has to be a 1. Either way it pairs. And this 1 became a 2. Now this one also will become a 2. So this gets forced. Let's just make this green to remind us that it's going to be the value it has to be. Just making some process. Now we see a few things to make progress. So the first thing is over in this area, this 2 has to be a 2 because actually what happens is this 3 cannot go down to this 2, so this cannot pair up because that will force, so if this 3 pairs up with this 2, that will force this 3 to pair up with this 2, and you can't have two threes here. The diagonal pattern gets broken. So actually the first thing I should have done is this 3 has to pair up with this 2. And now we see that this 2 by 2 area is isolated. Like if this 2 pairs up with this 1, then we have 3 numbers here, so that's not possible. So this 2 also actually cannot pair up with this 1, so we actually get a green cell here. This has to be a 2 no matter what. Since we know it's a 2 and we have 2 segments coming in here, we need 2 segments going out here. And that means this 1 now cannot pair with this 1. We already said it can't pair with the 2, so it has to pair with the 3. So we get this. And also in this area, let's look at this. These two ones can't pair with each other because what ends up happening is if they pair with each other, that means these two twos pair with each other. And if this is a 2, then that automatically forces this also to be a 2. So what that means is the two ones can't pair with each other, and that means each of the ones has to become a 2 because each of them pairs with a 2. So we get a cross here, and we know that it's going to go in this direction in some way, and this gets forced. So now let's see what happens if this let's see what happens if this 2 pairs up with this 2. What ends up happening is actually that would force, we know that this 1 becomes a 2, so it'll have to pair up with the 2 above. What this forces is actually this will force this and this for the 1 because we know it's a 2. But now since this 2, actually I'll just put it in and to show it. Now this 1 and this 2 here would cause a break. So again, a little bit of a look ahead, but that area, the two twos cannot pair up with each other. So that means this 2 has to pair up with this 1, and this 2 also has to pair up with this 1. That gives us a little more progress because these 2 are crosses now. We can resolve this area. So this 3 and 2 pair up, this 2 and 2. And this much gets forced. Now looking at this 2, obviously it can't pair up with the 3, it has to pair up with the 1 below. So we get this and this. Now this 1 can pair up with the 3 or the 2. So what we see is if it pairs up with the 2, then basically what happens is this 2 also becomes a 2 because this segment goes here, but this 2 does not have a 2 to pair up with or a 3. Like it doesn't have anything bigger to pair up with other than a 1 if this 1 pairs up with the 2. So that immediately breaks. So let's just take it back. And these 2 pair up with each other. So that gives us a little bit more. And also this because of the 1. So now let's just go around again marking some greens. So this 2 has to be a 2. This has to be a 2. This also has to be a 2. This one has to be a 2. And this, all of those. This one as well. Actually, this one didn't have to because it's next to the 3. Right. So I'm not getting much progress moving through. This also has to be a 2, but that doesn't give much either. Let's look back at this area. So if this is paired with this 2, that actually forces this to happen, but these 2 1s will also pair up and this breaks. So the 2 2s can't pair up with each other. That means these 2 will pair up with each other. So you have a 2 here and a 1 here. It forces this. Now this is a 2, but we don't know which 2 it pairs with. But we do get some crosses. And this is also a cross. So all of these are crosses. And we know that this is a 2. So this comes down this way and this comes down. This comes down. And now we see that this area, this 2 over here could either have been a 1 or a 3. Now it has to be a 3. So it has to pair with this. And that'll put this in. Now, so now this 1 over here cannot be a 2 anymore because 2 would leave this stranded. So it has to be a 1. That means it pairs with this. And that means these 2 pair up. You can also put this much actually. Now this actually has to be a 2. So these get crossed out. And if so this 3 has to go either down or to its right. And this itself will be a 2. Let's actually mark that. This will be a 2 by itself. Now if the 3 goes below, then what ends up happening is obviously you can't have this, but you also can't have this because it will break this 2. This has to be a 2 no matter what, because the 3 has gone down. Now this 2 will pair with this. So the 3 cannot end up going down, so it'll actually go right. So these 2 pair up, and that gives us a little more, and some more pairings as well. This is forced, these 2 are forced, and these. So some more of the loop now. Okay. Now we know that this is a 2 as well. So this will go further. Now we know that this has become a 2. So it couldn't pair with the 1 anymore. So it has to pair with the 2 below. That gives us a one more pairing here. And continuing on with the loop. Okay. Now we know that this is a 2 here as well. Now this 2 could pair up. Actually, let me highlight it. This 2 could pair up with either of the digits, but now it can't be a 2 because that would cause a branching. It clearly can't be a 3. So it has to be a 1. So that means this is a 1, and the only one it can pair with is this one. That means this 3 will pair with this 2. And we get this much, um, this as well, and this as well. All because these are 2s. We know all of these are 2s. So that gives us this progress. Now just counting the loop ends, there are 4 loop ends over here. That means obviously this can't go like this. So it'll reach here and this will go down. Now let's look at this. I think this loop cannot close. So this whole thing cannot close. So we can extend it here. Let's just check that the pairings are done correctly. So this is a 2. So it will not pair with the 1. So these two will pair up. This will pair up with what is supposed to be a 1, which is fine. These two 2s will pair up, which is fine. These two 2s will pair up, which is fine. And these two are also fine. So now we just have the bottom left to finish. This is a 2 no matter what. Now this cell can't be a 2 anymore. It has to be a 1. So that means that this cell would need to pair with this. So we have a 3 and a 2 here because of that. And that finishes this much. Now look at this 2 by 2 area. It's kind of isolated to itself. That means this 2 and 1 will pair with each other. Let's just so if yeah, yeah, so this 1 over here has to be a 2 no matter what. So we get these crosses because it would need to get into this 1. Now because of that, and we get this cross as well, because of that we know that this is a cross because no matter what it'll force this because of the 2 in the corner. So this is a cross that basically gives us the 1 and the 2 pairing, and this is a 2 and a 2, and this whole thing will close here. Now looking down over here, first of all, since this 1 is a 2 no matter what, and this 2 is a 1 as well, you can mark that as well. That forces this and some more crosses. Now if now this 1 obviously cannot be a 1, it can be a 2 or a 0. So it can't be a 2 anymore, too many crosses around it. So it has to be the 0, and it pairs with the 0 below. Now that means we basically have this corner to complete now, and what happens is this 2 can never be a 1. This 2 can never be a 1 because even if we avoid turning upwards right now, what will end up happening is we'll come back and take its top portion. So it can never be a 1. It has to be a 2. And that means it has to pair up with this. And we get our final pairings. Let's just finish that off and then we can finish the loop. So this is the solution. So very challenging puzzle, and I myself needed, especially solving on the online interface, I needed a bunch of settings, a bunch of different settings. I hope that wasn't too disruptive. I hope this was still instructive, and quite an enjoyable puzzle as well. Quite a difficult variation in general. As I said, this variant appears in Matej's ebook. If you liked it, then please look into getting the ebook so that you can solve more of this variant. And thanks, Matej, for the puzzle. It was quite a challenge. And thank you all for watching.